Welcome back to the next video in Python. This one is going to be on Matplotlib. So I hope you've been enjoying the Python series. I know that we've kind of jumped around a bit, but just keep an eye open from topic to topic, and hopefully one of these interests you, such like today. Matplotlib is a library in Python used for graphing and charting. And after this week, we also want to build on that and talk about Seaborn next week. So if you really like this session, tune in next week for Seaborn. So here's some basics to get started. First thing you need is Anaconda. You can download that from Anaconda website, and then what I'm going to show you is through Jupyter, the notebook. You can use other tools as well, like PyCharm or the IDLE that comes with Python, but in this case I'm going to show you Jupyter Notebook. Now you can head on over to the GitHub, and you can get all the information if you go to github.com/freeknowledgemission. You can see that here's the pin repositories. This is where we put all of our material. So in this case, Science and Tech is where Python is going to be. So anything you want to check it out from previous sessions, it'll be here. And then go, in this case, search for Matplotlib. This has the wrong date. Well, eventually I'll update that. So go in this folder, and here's the files that I'll talk about today, along with some descriptions. So I have the notebook, Python notebook here. That's what we'll open up and run. I'll start with a PowerPoint. Then there's a README that just kind of, on the default page, this is what you can see there. An example text is just a data load file that I'll use. So let's open up this PowerPoint real quick just to give you a brief overview of what we'll cover today. So if you've listened to any other episodes, you know that I follow the gentleman on pythonprogramming.net. He is an awesome instructor, so if you like this, go check out his videos. I just follow along and put my own interpretation to it and just share it through our meetup. Okay, Matplotlib, you can see here we're going to cover quite a few libraries. You can do so much with Python Matplotlib. So here's about 30. We're going to cover about the first 15 or so, first half, and then maybe in another session we can cover the other ones. If you do want to check it out, here's the resources. Just click on this link and it'll take you to his website. So I'll put this video in the description as well. Here is the IPython notebook. And what I've done is added all the graphs in here. So if you scroll down, we're going to go through all these. There's about a dozen different graphs that we'll cover. And then we'll go through the key points of code. A lot of it's being reused, but I'll just point out the critical lines that differentiate. So we'll start with basics. So in the beginning, here's the author, Harrison, from pythonprogramming.net. Here's the link you can reference. And he gives all the code on his website. So it's a good place to go to get started if you're just learning Python or even Matplotlib. So first one, basic line. This is a basic line that you want to chart, plot on a graph. What we're doing here, first import the library matplotlib.plyplot as PLT. You're going to notice that one on every single one of these, so I won't mention that one again. Then plt.plot, and what we're doing here is we're taking a list, so two lists on X and Y axis, and then we have to show the plot. So the coordinates here on X and Y, and we're just plotting a line. Simple as that, 3 lines. Next, we have legends, titles, labels with Matplotlib. So legends here would be this legend here, you want to label it, and then here's the title, and then the labels are over on the left and the right. So here again, here's our x-axis and our y. We're going to have 2 lines this time. Here is our label. So first line is part of the legend, and then second line is part of the other legend. Then our label is plot number, so our x, and then our y is important variable. And then title, plt.title, we're just going to reference the title here. Interesting graph. Then we also have to output it, so plt.legend and plt show. So now you have a 2-line graph with some extra features added in. Next one is bar chart and histogram. The important thing to distinguish here, I'll show you two, one bar chart, one histogram. They are different. Bar charts can be confusing to histograms, but a bar chart really shows a comparison between some values, where a histogram is more of a distribution of a holistic data set. So I'll tell you a little bit about that as I compare the two. But this one right here is a bar chart. So first is plt.bar, and then the two lists of numbers. We're going to label that example 1. And then here, plt.bar, we have this one we're going to change to a new color, G. Label it example 2, and then give it a new set of numbers. Now here's plt legend, which is on there, existent, X label, Y label, and then title. So here's just a simple bar chart, 2 data sets. Okay, now on to the histogram. What we're going to do here is a histogram, and we're going to show a larger range of numbers. So we have a much larger data set here, and we're going to group these into bins. So bins are ranges or groups of numbers. And we're going to do plt.histogram. So this is the histogram instead of bar chart. We have population ages, which is our first data set. Bins, our second data set. The type, we're going to show it as a bar, and then we're going to define it with the width of 0.8. So here, X label, title, the same stuff. So here's your histogram now, and it shows a group as a holistic data set. Okay, next, scatter plot. This is what a scatter plot looks like. Same thing here, import X and Y axis, so plt.scatter, your X and Y, label, color, K is for black, size 25. Generally, to make any distinguishable difference, size would be between 25 and up to 100. And your marker here is just a 0 for or an O for a dot. You could do other ones like 100 or an arrow. Just Google those and you'll find tons of different markers. You don't have to memorize these. Just use Google. And the rest of here is the same. Next is a stack plot. Stack plots are pretty commonly used. Here's what is an example here. Okay, now we're going to have 4 data sets, and this example is given the different number of hours consumed in a day. So 4 categories: sleeping, eating, working, and playing. And these add up to a full day, the 7, 2, 7, 8. And then we have the same data set so we can compare against them. So plt.plot, and we're going to color each of these. So this is magenta, cyan, red. K is for black instead of B for blue. And then label it. So that's your legend here. And then line width, we're going to make it 5. Then we make our plot. So plt.stackplot, and then put the 4 categories, put the 4 colors that you want to find. Oh, sorry, line width is the line width here, the legend. This one here, 4 colors is what denotes here. And you really, it's hard to label these within the graph, so legend's the way to go. You can annotate, and I'll get to that when we're talking about like stocks. You can annotate the top, peak, or different parts of the graph, which are useful. But this is, the legend's a pretty easy way to go. Okay, next is pie charts. So this is what a pie chart, everyone knows what that looks like. So slices, we're going to define here, 7, new data set. Activities, here's our 4 categories. And then colors, cyan, magenta, red, blue. Okay, so plt.pie, and then we're going to make it up into slices, activities, so that's our data set and our categories, and our colors, which are defined here. Then our starting angle, 90 degrees, that means we're going to start on the vertical position and work our way around. Add a shadow and explode. In this case, the explode is this slice right here. So the first value, 0, 0, and then explode the third value. And then auto percent, it auto fills in the percent for us, so we don't have to calculate that. And then that's it for a pie chart. Okay, next one is loading data with Numpy. You can also use CSV. I think it's more easy with Numpy, but if you really want to do CSV, it's very similar. So we'll import NumPy as NP. It's the standard syntax. Then you'll use NP right down here, load text. And in this example, what I had done is back to the GitHub. You'll see the example here. It's just a flat file, txt file with some random numbers, and there's a data set. So x and y coordinates np.load text, an example, give the text file delimiter with the comma and unpack to true. And then plt.plot, and then label loaded from file. So here it is, similar, we're just putting it into a file and grabbing it rather than making our own list. And as these data sets get larger, you're going to pull it in NumPy or data frame, and that's an easier way to do it. Okay, same stuff there. Okay, data from the internet. Now eventually what you're going to do is you're going to pull data, not necessarily create your own data sets or your own files, but you're going to pull it from APIs. So in this example, a lot of people will, when they're first learning Python, will use data sets from stock analysis as an easy way to graph things or look at the charts. So that's what we're going to do here. Pull it from Yahoo Finance. So Harrison has put it up on his site because the one on Yahoo is no longer working, but it just represents how it works. So he's stored it up there for us. So here we're going to import URL lib to do that, to get it from the URL. And then we're going to modify the dates too. We're going to, because the dates don't come in the way that they should. So in order to cleanse the data, this for loop, what this for loop does, I don't have an example of the file that comes in, but I'll kind of describe how it looks like. The first 10 lines are just describing the data that you're looking at, and then after that, so we're going to pull in, let's say, I think he uses Tesla for an example data set, and so I think it's been around for 5 years, 10 years, actually 10 years of data he's able to get. And the first 10 lines don't represent what we want. Then the next lines after that are the data points we want to chart or graph. And that has the word values in it. So what we're going to look for, if it doesn't have values, and then just take it out. So this is taking out any data that's not useful within the API. That's what the for loop is doing here. And I do have an error because I don't have that defined, the stock value. I think that's what it's asking. Yeah, stock data. I don't have that defined. I need to add that. But essentially what you're going to get is if you went to finance.google.com, you would see a graph of what the Tesla in the range that we're looking at here. Yeah, here's graph data. So next one, we're going to be inserting date stamps. So same stuff. Yeah, we have to prep it to get the date added in. So yeah, here we want the years added in here. So here we're going to have date. These are the data points we're going to add. Date, close price, high price, low price, open price, adjusted close price, volume, and then NP load, the load data. So here is what you can use for full year, partial year, number, month, day, number, day, hours, minutes, seconds. So that's what we're doing. We're going to PLT plot date, and we're going to do the close price. So the reason you want all these different plots is what we're going to do is we're going to show a candlestick graph. Candlesticks are very useful because you can plot many points all in the same place. So the high, low of the day, intraday, and then the close price and the open price. So I'll show you a candlestick here in one of the next ones. Basic customization. Okay, we're going to define here the AX1 subplot to grid. Okay. Actually, I don't know what this one is. I'm going to have to edit this part out. Yeah, we'll skip it. Okay, Unix Time, what he talks about with Unix Time is most data comes in at Unix Time, which is 1970. Anything after that, it starts, well, Matplotlib doesn't work on Unix Time, so you have to convert it. So he talks about here is the encoding. So you'll format bytes to update the number, and that's what this function right here is doing. And then plot to subplot to grid. And then a lot of the same code here. And then also just to mention subplot. Subplot is essentially multiple graphs within the same. So if you have one subplot up here, then you have a plot down here and a plot down here. So you could have, or you could have four all within the same frame. Essentially, that's what subplots are. Color fills. Let me show you what the color fill is before we describe it. Why you'd want to use color fill. Okay, yeah. Here's an example of subplot. It's not filled in, but you'd have a plot, a graph, and a graph. So color fills here. This is if we could take a point, a price, and draw a line. That's our price point, and then we could compare against it. So if it's below that price, it'd be red. We're in the negative. If it's above that price, we're in the green. It's positive, and we're just showing that. And then also we can thicken the line to show, maybe represent or color it. So the price at any point in time, the loss and the gain. So let's go up and show you that. We're going to make it red. Alpha is the opacity. And then the next line, gain, we're going to change the color to green. Leave the same alpha. Then here's so that's the line. And the fill between, same thing. Close price, where the close price is greater than the line, then it's going to be up and it's going to fill it with green. If it's below the line, it's going to be red, so less than here. And then we're going to get tick labels, is essentially how we fill it in. Okay, spines and horizontal lines, I'll show you what those. This is kind of like a grid per se. So I'll show you, here's like a spine here, and you can easily grid this too. So we're going to show you how we do that. So a spine would be useful as if you're plotting at any point in time, maybe a moving average, or let's say you're tracking a stock by week to week. It'll show you a certain point in time. So we're same blocks of code there. Okay, graph data, okay, figure, PLT figure, and then there's a subplot. Okay, same there, same there. Okay, here, spines. Left, set color to cyan. Right, set or do not make visible. Top, don't make visible. And left, add, make it thicker. So that's what a spine is, and that's how you define the spine. So just a simple block of code that we're adding in there to show that. Okay, here's a candlestick that I talked about, and I'll show it to you really quickly. The one disadvantage with Jupyter Notebook is I really can't zoom in. I mean, you could zoom into with the browser, but it's not going to. I really want to zoom into a week, for example. It's not going to give you that view. So you have to use like a pie chart or an IDLE to give you that view. But if you could see that, the nice thing about candlesticks is you get 4 data points all within one. So you get your low price, your maximum price, your intraday, and then a candlestick down here and a candlestick up here, and that's your intraday high and low. And then the color fill. So if it's green, that means the stock was up for the day. If it's red, the stock was down. So the close price is the bottom. It's the last price. If it's green, the close price is at the top. So you get 4 of those data points within a candlestick. So there is a new library that you import, and that's here, matplotlib.finance, import candlestick OHLC. And then lastly, to graph that right here, candlestick OHLC axis 1, the width, the color. This right here is a hex number, so what you can do if you want to customize your color, go to Google, search for hex color, and you get a palette, and you can move it around with your mouse, choose the color you like, it'll output the text number, you can copy and paste it here. That way you can get more specific than just RGB. Okay, so that's really the line that you need for your candlestick. Just the basic there. So that's it. That's the basics of the graphs. Maybe in the next part tutorial we'll cover some more of these, but you can just keep going. I think next week we're going to do Seaborn, so if you're interested in that, it's a really powerful tool for plotting. And I hope you enjoyed this video. If you did, share it with your friends, like, subscribe. You know what to do on YouTube. Just get the word out there to learn more Python. It'd be a much better place if we could all learn a programming language. Python is one of the most popular, especially because it's easy to learn. So I hope you found this useful, and comment and let me know if you are out there watching. Love to hear from you. Cheers.